Okay, so for question one, evaluate the following limits. So for question A, we have limit of x approaching 0 equals x over 2 minus root of x plus 4. Okay, so looking at this question, there's not much that you can really do right now. Obviously, we have to do something, but there's not much you can do. You can't really cancel anything out. You can't factor anything. You can't do anything yet. So what you actually have to do is multiply this fraction by the rational. So basically, I'm rationalizing the denominator is what I'm trying to do. And I can do this by multiplying the fraction by the opposite of this. So what I mean by that would be, so we can write limit of x approaching 0 equals x over 2 minus root of x plus 4. And then we can multiply this fraction by the opposite. So the opposite, I mean 2 plus. So this is 2 minus root x plus 4, and we can multiply it by 2 plus root of x plus 4. So we're basically rationalizing the denominator here, and obviously you have to multiply the numerator as well. So you just multiply it by the same, which would be 2 plus, x plus 4. And so here, so now we can just quickly simplify this out and write this as one fraction. So we can get x times 2 plus root x plus 4 over, sorry, I just want to center this, over 2 bracket 2 minus root x plus 4, 2 plus root of x plus 4. Okay, so now looking at this, you can see that there's actually a difference of squares in the denominator. So what I mean by that is, if you see, this is a term A, and this would be term B, and it's the same terms for here. So term A as well, and B as well. So the formula for the difference of squares is A minus B times A plus B equals A squared minus B squared. Okay, so looking here, we can see that actually the denominator is A minus B times A plus B. So we can just completely simplify the denominator by writing it as A squared minus B squared instead of having this whole big mess. So we can just quickly simplify that out and make that a quick step. So I'm just going to quickly write that out here. So it would be the limit of x approaching 0 equals, obviously the numerator still stays the same. So 2, or x times 2 root x plus 4. And then here in the denominator, we will have a squared minus b squared. So our a term is 2 squared minus root of x plus 4 squared. Just put brackets around there, and then we can just quickly simplify this out. Lim of x approaching 0 equals x 2 plus root x plus 4 all over 4, and then just the square root here, the root cancels out because it's squared, so you can just write x plus 4. Okay, so now the next step would be just to quickly simplify the denominator, since it's now just like just a bracket and addition and inside, and you have two variables here. You can just subtract, because it's 4 minus x plus 4, you can just simplify it to make it, you can just make it x, negative x, sorry, I just had a brain fart. But lim of x approaching 0 equals, so it would be x times 2 plus root of x plus 4, and then over negative x. See, basically we're just subtracting these terms, so the minus that, negative x minus 4, or whatever, it gets to a negative x. Okay, And then, so the next step would then be, you can just cancel out the x, and this gets rid of our fraction, which is what we need. Our goal this whole time has been to get this limit in its simplest form, so we can then apply the limit and solve. So just to quickly finally simplify this, we can just go lim of x approaching 0 equals, so the x's cancel out, and because there's a negative there, it's going to leave a -1 there. So it'll be -1 times 2 plus root of x plus 4. And then, so from here, now that we have this, we can just simply sub in the 0 for the x value. So because we can just do this, we just do that and solve since with the limit, and since the limit is x approaching 0, and we now have the fully simplified version of the initial formula up here, right? The x over 2 minus root x plus 4, the simplest version of that formula would be -1 times 2 plus x root x plus 4. So now all we have to do is lim of x approaching 0 equals -1 times 2 plus 0 plus 4, and then we just continue to solve, so it would just be -1 times 2 plus root 4, which is 2, so here plus 2, and then we can just quickly simplify and write this next line, because we know that this will be 4, so we can just say the limit of x approaching 0 is -4. So there we go. That is our final answer for A. If you can see that right there, that is our final answer. For the limit of x approaching 0 equals, the limit would be 4. So there we go for that one. I'm just trying to make sure this is still centered, sorry. So here, I'll just draw a quick line down the middle. Okay, so now for B, we can see that we have the limit of x approaching 4 equals bracket 1 over x minus 4 minus 8 over x squared minus 16. And then that's what we got going on here. So this one's a bit more difficult, but at the same time, it's not. So now we can analyzing this limit here. The first thing that I notice is here, looking back on equation 1, or equation A, looking at the first differences rule here, not first differences, difference of squares, we can see that this actually, if you think, so there's a square root of 16, right? So 4 is the square root of 16, and x is squared, so that I notice right away that this denominator here is actually a squared minus b squared. See, there's the minus there, which I know equals a minus b times a plus b, right? So assuming this would be my a value, and that this would be my b value, the root of this. So this, I'm going to write this off to the side. B equals 4, okay? So I know that b squared is 16, and a squared would be x squared. So here it should be a minus 4 times a plus 4. So we can rewrite this limit here, this second bracket, second fraction, x minus 4 minus 8 over x minus 4 times x plus 4. Okay. So the next thing that we would do is, now that we have this, and it's just a subtraction, we're just subtracting a fraction from a fraction, right? So what we need to do that is actually get a common denominator. So the first thing that I need to do is figure out what these two what I need to multiply these two by to make them the same. So I notice that there's an x minus 4 here, and there's also one here. So to multiply to get a common denominator, all I have to do is just multiply it by x plus 4. So I multiply, to get the common denominator, I'm going to do this. I'm going to multiply, so the limit of x approaching 4 equals 1 times x plus 4 over x minus 4, x plus 4, and then minus 8 over x minus 4, x plus 4. And then, so now that we have that, we can just rewrite it as one fraction, because just so it's not subtraction, we can just write the numerator as the same. So it would be limit of x approaching 4 equals, because it's times 1, we can just write x plus 4. Sorry, I don't even need that bracket there. But x plus 4 minus 8, because there's a minus there, and then all over x minus 4, x plus 4. Okay? So then, from here, the next thing that we would do would be just to simplify the numerator here. Because again, just like last time, we have a plus 4 minus 8. So we can just quickly simplify, instead of having x plus 4 minus 8, to just writing it x minus 4, right? So we can just quickly write that out. The limit of x equals 4 equals x minus 4 over x minus 4, x plus 4. Okay, so now looking at this, there's not much more that we can really do. There's only one more thing that I noticed, and I noticed that there's an x minus 4 up here, and there's one down here as well. So the last thing that we can do, the only other thing that we can do to this to fully simplify it, would be to cancel out the two x minus 4s, which would leave us with limit of x approaching 4 equals 1 over x plus 4. Right? So that's what our final simplified version of this limit would be. And so now the only thing that we have to do from here is actually just apply the limit in for the x value and solve. So for this, all I would do would be limit of x approaching 4. And again, because it's x approaching 4, I'm plugging in 4 for x. So I do 1 over bracket 4 plus 4. And then just quickly simplify that out to get limit of x approaching 4 equals 1 over 8. And this right here is also my final answer. So that is question 1, and there we go. Okay. Sorry, I just want to make sure it's all in frame. But, okay, so for question 2, we have given the limit of x approaching pi of f of x equals -3. The limit of x approaching pi of h of x equals 8, and the limit of x approaching pi of g of x equals 49. Use the property of limits to evaluate limit of x approaching pi equals 0.75 h of x plus 14 f of x all over 7 root g of x. So looking at this, there's honestly not much we can do. There's not much you can do to simplify. There's not much you can really do in terms of anything to evaluate before plugging in values. So for this question, the only thing that you can really do, sorry, I still want to make sure this is all in frame, but the only thing that you can really do is just plug in the values for the f of x, h of x, and g of x limits, because those were given to us. So all we really need to do here is plug those in. So given that these that is that, and f of x is -3, h of x is -8, and g of x is 49, I'm just going to rewrite this and plug these numbers in. I'm going to make sure they're good. So sorry, here. So we have 0.75 h of x, which is -8, plus 14 f of x, which is -3, all over 7 times root 49. So now all we have to do is just simplify and solve. So 0.75 times 8, or negative 8, would just be negative 6. And then 14 times negative 3, I'm just going to use my calculator. 14 times 3 equals 42. So it would be negative 42, because the 3 is a negative, and it would be 7 times 7, because the root 49 is 7. So then we can just simplify this out to negative 6 minus 42 would be negative 48 over 49. And this here would be our final answer. So sure this is all good. Okay, so for question 3, determine the equation of a tangent line to f of x equals 9 over x squared plus 5 when x equals 3. Okay, so the first thing that I know is that because it's determined the equation of a tangent line, I know that my final answer is going to have to be in the form of y equals mx plus b, because that is the equation of a line, right? So I already know x equals 3, meaning I'm trying to solve for b, m, and y, okay? And so to do this, I have to do a bunch of different things, right? M is the slope, b is the y-intercept, and y is just the point where it intersects with this function here, right? So the first thing that I'm going to do is solve for the y value, because I feel it just makes most sense to solve for the point where they intersect first. So to do this, all that I have to do is plug in x equals 3 into the original function. So to do this, I just have to do f of 3 equals 9 over 3 squared plus 5. So this we can just solve quickly. So f of 3 equals 9 over 9 plus 5. So f of 3 would equal 6, because that's 1, and then plus 5 equals 6. So with this, we know that y equals 6, and that it passes the point of intersection is 3, 6, right? So x equals 6, y equals 6 from this as well, okay? So the next thing that we have to do is solve for the m value here. And to do this is to find the slope. So this equation here is a bit tricky. It's a bit tricky to get the derivative of, because to find slope in calculus, what you do is you find the derivative, right? So getting the derivative of 9 over x squared plus 5 is a little tricky. So I'm just going to quickly rearrange it to rewrite it as 9x to the negative 2 plus 5. Okay, this is the same as 9 over x squared. It's just rewritten with a negative exponent. And so now with this, I can take the derivative and I can just solve, or I can just get the derivative. And so the derivative of this would be negative 2 times 9, which is negative 18x. And because it's a negative, negative 2 minus 1 would be negative 3, right? With this, now, because it's a negative exponent, I'm just going to switch it back. This is just a little challenging to work with. So I'm just going to switch it to negative 18 over x cubed. Okay, so this is why this is the derivative of the first function. And so now all I have to do to solve for the slope is just plug in the m value, plug in the x value to solve for the m value. So I know that again, x equals 3. So f prime of 3 equals negative 18 over 3 cubed, which would equal f prime of 3 equals negative 18 over 27. And then I can just quickly simplify that to make it f prime of 3 equals negative 2 over 3. So with this, I have m equals negative 2 over 3. I'm just going to write that there because that's in another important part. And so now the next part that we have to do is just take everything that we have found here and plug it back into y equals mx plus b so we can solve for b. So if we take y equals 6, x equals 3, and m equals negative 2 over 3 and plug them in, we get 6 equals negative 2 over 3 times 3 plus b, okay? And so now all we have to do is just solve. So 6 equals negative 2 plus b, because negative 2 over 3 times 3 is just negative 2. And then all we have to do is isolate b here, so 6 plus 2 equals b, and therefore 8 equals b, right? So now we have b equals 8 as well. And so for our final answer, all we have to do is just rewrite this formula with the b and m value. So our final answer for the tangent line to f of x equals 9 over x squared plus 5 would be y equals negative 2 over 3x plus 8. Okay, so for question 4, I'm just going to write it down here. Question 4, differentiate the following functions. Simplifying is not required. So for question A, it is y equals 2x cubed minus 3 times 1 over x minus x squared. So the first thing that we need to do to differentiate is, well, what that means is basically we're trying to find the derivative. And in this case, what we can do to do this is, because this is all clumpy and a big mess trying to get the derivative of this, is what we can do is use a rule called the product rule. And the product rule is basically a b prime equals a prime b plus b prime a. And this means that, so basically you can label your first term as A and second term as B, because this will be your first term and this will be your second, and we're trying to find the derivative of both, right? So because we're trying to find this, we can now label A as this and B as this. So what I'm going to do is write A equals 2x cubed minus 3, and then A prime equals, so to get the derivative, 3 times 2 is 6x squared. Derivative of negative 3 is nothing, so we leave it at that. And then for B, we just equal 1 over x minus x squared, and B prime would equal 1 over x squared minus 2x. So with this now, all we would have to do is substitute in the A prime, B, and B prime values into this product rule formula here to get the derivative and properly differentiate this function. So that's exactly what I'm going to do here. I'm just going to write y prime. So to differentiate the function, we use y prime in this situation, and we just do a prime, which is 6x squared, times b, which is 1 over x minus x squared, plus b prime, which is 1 over x squared minus 2x, times a, which is 2x cubed minus 3. And this here would be our final answer and fully differentiated function from the original one. So moving on to B, it's a bit more challenging because of the exponents involved. And you'll see why later on once we start getting the problem going. But we can start it up pretty much the same. So to start it, we can just rewrite AB prime equals A prime B plus A b prime. And so this means we're just gonna make this equal to a as well, and this one equal to b. So I'm gonna say a equals 3x squared minus 5 to the power of 3. And then I'm gonna get the derivative of this, so a prime equals, and so this is where it gets a little tricky. So for the derivative, we're gonna use crown rule, meaning we're gonna bring the 3 over and put it in front and get the derivative of the outside, and then what we're gonna do is get the derivative of the inside and multiply it afterwards. So it's gonna look like this. So we're gonna bring the 3x squared minus 5, and then because 3 minus 1 is 2, and then what we do is multiply it by the derivative of the inside, which would be 6x. So then we can just quickly simplify really quick and just make 6x times 3, so 18x, 3x squared minus 5 squared. And then we can say b equals 4x plus 1 to the power of 8. And then so b prime, we do the same thing for crown rule, and we bring the 8 down and do the bracket, get the derivative of the bracket and multiply it as well. So we bring the 8 down, 8 times 4x plus 1 to the power of 7 times 4. So we can just again simplify and make this 42 4x plus 1 to the 7. And then, so to get our final answer, all we have to do now is, now that we have our b prime values with this, and our a value and b value, is just sub it back into the product rule equation. So all we would have to do is y prime equals a prime, which is 18x times 3x squared minus 5 to the power of 2 times b, which is 4x plus 1 times to the power of 8, plus a, which would be 3x squared minus 5 to the power of 3, and times b prime, which is 42 4x plus 1 to the power of 7. And that would be your final answer for b. Fully differentiated function would be y prime equals 18x times 3x squared minus 5 squared times 4x plus 1 to the power of 8 plus 3x minus 5 to the cubed times 42 times 4x plus 1 to the power of 7. So that would be your final answer for both. Question 5, a pickle company is designing a cylinder-shaped pickle jar with a volume of 1,200 milliliters. What dimensions of the cylindrical jar will minimize the amount of material needed for each can? So the first thing that I'm going to do to solve this is I'm going to sketch out a cylinder. I know I need H, and I know I need R. So I have the volume, the formula for volume and the formula for surface area. And because the question has given me volume, I'm able to rewrite the formula for volume as 1,200 equals pi r squared h. So the next step that I would do would be divide both sides. Here, I'm just going to rewrite this over here to give myself some more space. The next step, so here, 1,200 equals pi r squared h. The next step would be divide both sides by pi r squared equals pi r squared h over pi r squared, because you can isolate the h. This will allow us to get h equals 1200 over pi r squared. Okay, so now that we have h isolated, we can plug in our value that we have for h into our surface area formula. So what I'm going to do is SA equals 2 pi r squared plus 2 pi r h, which is 1200 over pi r squared. So after we've done that, the first thing that we can do is cancel out the pi, the r, and the pi, and the r squared. So we can rewrite this as surface area equals 2 pi r squared plus 2 times 1200 over r. The next thing that we can do is just quickly simplify. So SA equals 2 pi r squared plus 2400 over r. And now that we have this, there's not much more simplifying that we can do. So what we're going to do is take the derivative. So SA primed equals 4 pi r, because it's the 2 times 2, and that 2 minus 1 is r, or is 1, and then plus minus 2400 r to the power of negative 2, because 2400 over r can just be rewritten as 2400 to the power of negative 2, which would then be written as surface area prime equals 4 pi r minus 2400 over r squared, just to get rid of the negative exponent. So now what I would do, that I have this, is plug in 0. I set it equal to 0, and I can start solving for r. So I have 4 pi r minus 2400 over r squared. And the first thing that I could do is bring the 2400 over r squared over to the 0 side. So 2400 over r squared equals 4 pi r. This allows me to isolate and work around a bit easier, and it's just going to make it a bit easier. And sorry, this is pi over 1. So then I can just write, to isolate, 2400 equals 4 pi r over, because it's 4 pi r over 1, I can just say it is then 4 pi r, and then multiply it by the r squared, resulting in an r cubed. Okay, so now that I have this, I'm going to divide both sides by 4 pi, so 2400 over 4 pi equals 4 pi r cubed over 4 pi, which cancels out these two 4 pi's. So I'm just going to do a little arrow bringing me up to here. And so now that I have this, I can plug in, because I have r cubed equals, I can just factor out the 2400 at the bottom and the 4 to make it 600 over pi. And I can just continue to solve for r. So I'm going to go r equals cubed root of 600 over pi. I'm just going to quickly type this in my calculator. And I get r equals 5.7588. And so this I'm just going to simplify down to 5.76. So now that I have r equals 5.76 as that dimension, what I have to do is I plug this in to the original formula for the volume, and I solve for h. So what I'm going to do is I'm going to take volume, again, equals pi r squared h. I'm going to say 1200 equals pi times 5.76 squared times h. And then to isolate this, I'm just going to divide both sides by pi times 5.76 squared. Sorry, I'm just going to rewrite this square bracket here. And then after doing that, I have h isolated. And with this, I can just punch this into my calculator, which I'm just going to quickly do. 1200 divided by pi times 5.76 squared, which gives me 11.5. So with this, I can now say that the dimensions for the jar that provide the smallest material for the cans will, sorry, I just got a notification on my phone there. I just want to make sure it's back. The cans will be height at 11.5 centimeters and radius of, we said, 5.76 centimeters. And that's because the radius of the can will be 5.76 centimeters and the height will be 11.5. So those dimensions will provide the smallest amount of materials to make the can that holds the pickles that are 1200 milliliters. So that is the answer. The radius is 5.76 and the height is 11.5 centimeters. Okay, for question 6, it says a farmer has 700 meters of fencing available to enclose a rectangular area for animals. He plans to use existing fencing as one of the sides of the rectangle. What should the dimensions be in order for him to maximize the area for animals? So the first thing that I'm going to do is draw out this shape. So I'm going to use the dotted line for existing fencing, and I'm going to use the straight line for the new fencing. And I'm just going to label this as W, L, and W. So the first thing that we know is that the perimeter of this area of the new fencing that will be put in is going to be P equals 2W plus L. And we also know the area for this shape will be A equals LW. So the first thing that we can do is, because we have the 700 meters, we can plug that into the perimeter. For the perimeter equals 2W plus L. So the next thing that we want to do is try and isolate this L. And to do this, we're just going to take 200 and subtract it by the 2W by bringing it over to the other side. So this will allow us to sub in 200 minus 2W into the equation for area. So that's what we're going to do right here and make it A equals 200 minus 2W times W. And we're just going to quickly apply that into the bracket just so we can quickly get 700W minus 2W squared. Okay, and now what we're going to do is take the derivative, because there's not much more we can do with this. So we need to find and take the derivative in order so we can try and get this value for W. So what we're going to do is take the derivative, which is going to give us 700 minus 4W. Okay, and with this, there's also, again, not much more simplifying or anything like that we need to do. So right away, we can go in and set it equal to 0. So I'm just going to set that to 0 really quick. 0 equals 700 minus 4W. And then now I'm going to solve for W. So I'm going to get negative 700 equals negative 4W. And then I'm going to get negative 700 over negative 4 equals negative 4 over W over negative 4. And that's going to cancel out. And I'm just going to get 175 here equals W. And so with this 175, we can sub that back into the original perimeter equation and solve for the L value. And so that's what we're going to do right here. We're just going to rewrite P equals 2W plus L, and then we're going to sub in 700 equals 2 times 175 plus L. And so with this, we're just going to solve for L quickly, and we'll get 700 equals 350 plus L, and then 700 minus 350 equals L, so 350 equals L. So with these two values for W and L, we have now found the dimensions to maximize the area for the shaded area. So all we have to do is just write our therefore statement and say the dimensions that will maximize the shaded area that will maximize the area for animals would be W equals 175 meters and L equals 350 meters. And that would be your final answer for question 6. Those would be the final dimensions that would maximize this area for the farmer. Okay, for question 7, it says, determine the equation of a tangent line for the following function. Use exact values in your solution. For the function is f of x equals x times e of x, e to the power of x, and where x equals 1. So the first thing that I realize that we have to do is we're going to need our answer to be in the form of y equals mx plus b, considering it's the equation of a slope. So there's a couple things that I can do so. We already have the x value, which we know is x equals 1. So the first thing that I'm going to do is just receive this y value. And to do this, all I have to do is plug in 1 for the x value. And so all I'm going to do is plug in f of 1 to f of x, and which is going to give me f of 1 times e to the power of 1. So this is just going to allow me to write f of 1 as a simplified version, because anything to the power of 1 is itself, and anything times itself is itself. So we can just say that f of 1 is e. Therefore, y equals e. And the point that this tangent line will cross is going to be 1e. So now with that, the next thing that we need to do is find the m value. And to do this, what we have to do is take the derivative. So to take the derivative, I'm going to take the derivative of f of x, which is going to give me e of x plus x e of x. And so with this, I'm now going to plug in my x value of 1 again, and I'm just going to solve for the m value. So I'm going to plug in f prime of 1 equals e of 1 plus 1e1, which is going to give me 2e, because it's just e to the power of 1. Again, 1 times e is just e, and e to the power of 1 as well is just e. So it would just be e plus e, resulting in 2e. And so I can then say from that m would equal 2e. So with this, I can now plug these values back into the y equals mx plus b formula, in order to solve for b. So I'm just going to rewrite y equals mx plus b, and I'm going to plug in these values. So e equals 2e times 1 plus b. Okay? And so now all I have to do is isolate and solve for b. So what I'm going to do is I can rewrite this as e equals 2e plus b. And then what I'm going to do is just isolate the b by bringing the 2e over. So e equals negative 2e plus b. And I'm just going to get negative e equals b. And so now that I have my b value, I can finally write my final answer by just plugging in the b and m values into the equation y equals mx plus b. So for this question, the equation of the tangent line for the function would be y equals, the m value is 2e, so y equals 2ex minus e. And that would be our final answer. So that would be our answer for this question. Yeah, it's done. Okay, so for question 8, sorry, I'm just going to write it down here. Question 8, the population of an ant colony can be modeled by the equation P of n equals 975e to the exponent of 0.75 n, where n represents the time in 30-minute intervals. A, what is the initial population of the anthill? And B, what is the rate of change after 4.5 hours? So for A, all that I have to do is receive the initial population of the anthill. So to do this, what I have to do is just put in 0 for n, because it is going to be the initial population, meaning before it has started, meaning, sorry, I just got a notification on my phone. I want to make sure everything's fine. But yeah, I can just plug in 0 for n, and that will give me the initial population. So what I have to do is do P of 0 equals 975e times 0.75 to the power times 0. Okay? So now that I have that, all I have to do is just solve for P of 0. So to do this, I can just quickly write P of 0 equals 975 e to the exponent 0, because 0.75 times 0 is 0. And then I can write that to be P of 0 equals 975 times 1, because any number to the exponent of 0 is 1. And from there, I can just say that P of 0 equals 975. So therefore, the initial anthill population is 975 ants. So that would be our answer there for part A. So for part B, we're doing something somewhat similar. So the first thing that we have to remember is that n represents the time in 30-minute intervals, and it is asking for us what is the rate of change after 4.5 hours. So I'm just going to quickly convert 4.5 hours equals 9 30-minute intervals, right? Because half of an hour is obviously 30 minutes. So there's 8 30-minute intervals in 4 hours, and then with 0.5 an hour, that would just be an additional interval. So 9 30-minute intervals. So because it's 9 30-minute intervals, that means our n value for the equation will be 9. So all I'm going to do is just plug in P of 9 equals 975e times 0.75 times 9. And now all I have to do is just solve. I'm sorry, I did that step wrong. I did that wrong. I did that completely wrong. Because this question's asking for us to find the rate of change, what I actually need to do is, now that I have this n value of equaling 9, I can then write my first step, because I'm trying to find the rate of change. What I have to do is find the derivative of p of n. So I do p of n equals 9. So the derivative of this would just be using chain rule. So I can just quickly write 975 e 0.75 n times 0.75 because of the e there, right? Because of so the e exponent would be, the derivative would just be 0.75. So now with this derivative, I can sub in this 9. So I can go p prime of 9 and then solve for my final value. So I can say p of 9 equals 975 e times, or to the power of 0.75 to the power of 9 times 9 times 0.75. And just to simple this out, I'm just going to quickly toss this in my calculator just so we can get our final answer, because these are some wacky numbers. So I'm just going to quickly go 0.75 times 9, 6.75, 975 times e, 6.75, 0.25 times 0.75 equals. Okay, so this equals 624,530. So with this, I can say that the rate of change at 4.5 hours would be 624,530 ants. And that is my final answer for B, and that is how you would solve this question.